Question number 1a, we have to express x squared plus 6x plus 5 in the form x plus a whole squared plus b, where a and b are constants. So the equation is x squared plus 6x plus 5. And to convert it into this form, we can first expand it. So this will become x squared plus 2ax plus a squared plus b. Now comparing the coefficients on the left and the right hand side. So the coefficient of x on the left hand side is 6 and on the right hand side it is 2a. So we can write 2a will be equals to 6. So the value of a will be equals to 3. Comparing the coefficients on the left and the right hand side. On the right hand side it is a squared plus b. And on the left hand side it is 5. So this will be a squared plus b equals to 5. We already have the value of a, which is 3. So this will become 3 squared plus b equals to 5. So b will be equals to 5 minus 9. The value of b will be equals to minus 4. Once we have the values of a and b, we can write the final expression as x plus 3, as the value of a is 3 and the value of b is minus 4. So this will become x plus 3 whole squared minus 4. In part B, it says that the curve with the equation y equals to x squared is transformed to the curve with the equation y equals to x squared plus 6x plus 5. We have to describe fully the transformations involved. Now, from the previous part, we already know that x squared plus 6x plus 5 was converted to the form x plus 3 whole squared minus 4. Now, if we have the equation y equals to x squared and it is converted to the form, we can write it as x plus 3 whole squared minus 4, as this is the same thing as x squared plus 6x plus 5. Now, this plus 3 represents a translation of minus 3 units in the x direction, and this minus 4 represents a translation of minus 4 in the y direction. So we can say that it was a translation, and the translation vector was minus 3 and minus 4. In question 2, the function f is defined by f of x is equals to 2 upon x plus 2 whole squared for x greater than minus 2. In part A, we have to find f of x with limits infinity and 1. So in the first step, we'll integrate the expression for f of x. So to integrate, we'll first bring the x plus 2 to the power positive 2 in the numerator, and this will become x plus 2 to the power minus 2. Integrating this, we'll get 2 into x plus 2 to the power minus 1 divided by minus 1. And we can simplify to write it as minus 2 upon x plus 2. And the next step, we'll substitute the limits. So the upper limit is infinity. So substituting infinity in place of x, we'll get minus 2 upon infinity plus 2. And we'll subtract it from the limit, so lower limit, which is minus 2 divided by 1 plus 2. Now minus 2 divided by infinity, that will be equal to 0. And this will become minus minus plus 2 upon 3. So the final answer will be equals to positive 2 upon 3. In part B, it says that the equation of a curve is such that dy dx is equals to f of x. It is given that the point minus 1, 1 lies on the curve. We have to find the equation of the curve. Now to find the equation of the curve, we integrate the expression for dy dx. We know that dy dx is equals to f of x, which was 2 upon x plus 2 whole squared. In the previous part, we already integrated it, so we can write it as y will be equals to minus 2 upon x plus 2, and we can write a constant plus c. To find the value of c, we'll substitute the values of x and y. So y is minus 1, and this will be minus 2 upon, so x value is minus 1, so this will become minus 1 plus 2 plus c. So this will be minus 1 is equals to minus 2 upon 1 plus c. So c will be equals to minus 1 plus 2, which is equals to positive 1. Once we have the value of c, we can write the final equation as y equals to minus 2 upon x plus 2 plus 1. In question 3, we have to solve the equation 3 tan square plus 1 is equals to 2 upon tan square for theta greater than 0 and less than 180. So in the first step, we can cross multiply and write it as 3 tan to the power 4 plus tan squared, and bringing the 2 on the right hand side, we'll get minus 2 equals to 0. Now we have an equation in terms in tan to the power 4 and tan squared. So to simplify this, we can use a substitution where x is equals to tan squared. So this equation can be written as 3x squared plus x minus 2 equals to 0. Factorizing this, we'll get 3x squared plus 3x minus 2x minus 2 equals to 0. Taking 3x common, this will become x plus 3 minus taking 2 common over here. So this will be x plus 1 up here. And taking 2 common over here, this will become x plus 1 equals to 0. So 3x minus 2 and x plus 1 will be equals to 0. So the values of x will be 2 upon 3 and x will be equals to minus 1. Now the substitution we used was x is equals to tan squared. So we can write tan squared x will be equals to 2 upon 3 and tan squared x will be equals to minus 1. As the square root of a negative number is not possible, so we can ignore this value. Now finding tan x, so x will be equals to tan inverse of, so it will be taking the square root of 2 upon 3 as it was a tan squared. So square root of 2 upon 3 is 0.816, and then finding tan inverse of the answer. So tan inverse of this answer will be 39.23. Now the basic angle is 39.23 degrees. And as it is a square root, so we can have both positive and negative values. And the range of x is from, or the range of theta in this case is from 0 till 180. So we'll make 39.23 in the positive quadrant of tan, which is the first quadrant, and in the second quadrant, as tan is negative in the second quadrant, and we can take the negative value as well due to the square root. So this will be 39.23. Finally, finding the value of theta. So the first value of theta will be 39.23, and the second value will be 180 minus 39.23. Now, as we have to give our answer in angles to one decimal place, so the final answer will be 39.2, and the second answer will be 140.8 degrees. In question 4, a curve has equation y equals to 3x square minus 4x plus 4, and a straight line has equation y equals to mx plus m minus 1, where m is a constant. We have to find the set of values of m for which the curve and the line have two distinct points of intersection. Now, as we have an unknown constant m over here, and there's a quadratic equation, so we'll be using the discriminant b squared minus 4ac. Now, in the first step, we'll equate the two equations. So this will become 3x squared minus 4x plus 4, the equation of the curve, and we'll equate it to the equation of the line, which was mx plus m minus 1. Bringing the equation of the line on the left-hand side, we'll get 3x squared minus 4x minus mx plus 4 minus m plus 1 equals to 0. Simplifying this, we will get 3x squared, and taking x common over here. So if we take positive x common, this will become minus 4 minus m, and this is a 4 plus 1, 5. So this can be written as 5 minus m equals to 0. Now taking b squared minus 4ac, so this will be, so the value of a, which is a coefficient of x squared, is 3. The value of b, the coefficient of x, is minus 4 minus m, and the constant term is 5 minus m. Applying b squared minus 4ac greater than 0. So this will become minus 4 minus m whole squared minus 4 into 3 into 5 minus m greater than 0. Expanding minus 4 minus m, so that will become 16 plus, so that will become an 8m plus m squared. This will become 4 times 3 is 12, 12 times 5 is 60, so this will become minus 60, and minus 12 and times minus m will become a plus 12m. Simplifying this, we can write it as m squared, 8m plus 12m is a 20m, and 16 minus 60 will become a, so that will be a minus 44, greater than 0. Simplifying this, we can write it as m plus, so this value will become 22, and the other value will be m minus 2, greater than 0. Now, once we have the two values of m, to give the correct inequality sign, we can first represent them on a quadratic graph. The upper value is positive 2, and the lower value is minus 22. Now, as it is a greater than 0, it means we have to move towards the right from positive 2 for it to be greater than 0, and towards the left from minus 22. So the values of m will be greater than positive 2, and m will be less than minus 22. In question 5, in the expansion of a plus bx to the power 7, where a and b are non-zero constants, the coefficients of x, x squared, and x to the power 4 are the first, second, and third term respectively of a geometric progression. We have to find the value of a and b. Now, in the first step, we'll try and find the coefficients of x, x squared, and x to the power 4. We know that the expansion formula for a plus b to the power n is a to the power n plus nc1 a power. So this is n minus 1 and b to the power 1 plus nc2 a to the power n minus 2 and b to the power 2 and so on. Now, as we need the coefficient of x, x squared and x4, so we can first use, so as the expression is a plus bx to the power 7, to get the coefficient of x, we can use nc1, so that will become 7c1 a to the power 7 minus 1, which is 6, and b to the power 1, so that will become bx to the power 1. 7c1 is 7, so we can write it as 7 a to the power 6. The b will remain as it is, and this will be x. For the coefficient of x squared, so we'll be using 7c2, so this will become 7c2 a to the power, so that will become 7 minus 2, that will be 5, and b to the power 2, so that will become bx to the power 2. So 7c2, if we substitute this in the calculator, so 7c2 will be equals to 21. So that will be equals to 21 a to the power 5 b squared x squared. And for the coefficient of x4, we can use 7c4. So that will become 7c4 a to the power. So that will become 7 minus 4, which is 3. And this will be bx to the power 4. So 7c4, if we substitute this in the calculator, 7c4 is 35. So that will be 35 a cube b to the power 4 x to the power 4. Now, as these terms are the first, second, and third terms of a geometric progression, it means that the common ratio, so if we divide the second term by the first term, that will be equals to if we divide the third term by the second term. So first, dividing the second term by the first term, the second term is 21. The coefficient of the second term, which will be 21 a to the power 5 b squared, and the coefficient of x was 7a power 6b, and that will be equals to the third term, which was 35 a to the power 3 b to the power 4, and we'll divide by the second term, which was 21 a to the power 5 b squared. So this will cancel out with 3. 7, this is 7 3 times, 7 5 times. So this will cross multiply. We can write it as 9 over here. So this will be 9. This 6 and this 5 will cancel out. So this will become a, and this b and this will cancel out, and this will be 9b upon a. A cube and a5 will cancel. So in this case, we'll have, so this will become 5 over here and a squared in the denominator. And this will cancel out, and we'll have b squared in the numerator over here. Now, a and a squared will cancel, b and b squared will cancel over here. So the final expression will be 9 is equals to 5b upon a. As we have to find the value of a upon b, so we'll take a on the left hand side and b also on the left hand side, so that will become a upon b, and this will be equals to 9 will come on the right hand side and divide by 5, so this will be a upon b will be equals to positive 5 upon 9. In question 6, the function f is defined by f of x is equals to 2x upon 3x minus 1 for x greater than 1 upon 3. In part A, we have to find an expression for f inverse of x. So in the first step, we'll write y in place of f of x, and this will be 2x upon 3x minus 1. Now exchanging the values of x and y, so this will become x equals to 2y upon 3y minus 1. Now to make y the subject, we'll first cross multiply. So this will become 3xy minus x equals to 2y. Bringing the y on the left hand side, so this will become 3xy minus 2y equals to x. Now taking y common, so this will become 3x minus 2 is equals to x. So y will be is equals to x upon 3x minus 2. So we can write the final answer as f inverse of x will be equals to x upon 3x minus 2. In part B, it says show that 2 upon 3 plus 2 upon 3 into 3x minus 1 can be expressed as 2x upon 3x minus 1. So in the first step, we can take the LCM. So the LCM will be 3 and 3x minus 1. So this 3 will multiply by 3x minus 1. So this 2 will also multiply by 3x minus 1. So this will become 2 into 3x minus 1, which is 6x minus 2 plus 2. Simplifying this, we'll get 6x minus 2 plus 2 will cancel out. And in the denominator, we have 3 into 3x minus 1. 3 and 6 will cancel. So the final answer, which we had to prove, was 2x upon 3x minus 1. In part C, it says state the range of f. Now, to state the range of f, we know that the value of x is greater than 1 upon 3. Now, as f can be expressed in the form 2 upon 3 plus 2 upon 3 into 3x minus 1. And we know that x must be greater than, so it was given as greater than 1 upon 3. So as we increase the values of x over here, so for very large values, this will become 2 upon any large value will be nearly a 0. But the minimum value that f of x will have will be 2 upon 3. So f of x, we can say, will always be greater than 2 upon 3. As even if this becomes a zero, nearly a 0, this will remain where it is, 2 upon 3. So f of x will at least be a 2 upon 3 or greater. In question 7, the first and second terms of an arithmetic progression are 1 upon cos square and minus tan square upon cos square respectively, where theta is greater than 0 and less than half pi. In part A, we have to show that the common difference is minus 1 upon cos to the power 4 theta. Now, when it's an arithmetic progression, the common difference is given by the difference of two consecutive terms. So in this case, we can take the difference of the second and the first term. So the common difference will be the second term, which is minus tan squared upon cos squared minus the first term, which is 1 upon cos squared. So taking the LCM, this will become minus tan squared minus 1 upon cos squared. Now we know that tan squared is equals to sine squared upon cos squared. So we can first simplify the numerator separately. So the numerator will become, so this in place of tan squared, we can write sine squared upon cos squared minus 1. And we can simplify the numerator by taking the LCM. So this will become minus sine squared minus 1 upon cos squared. Now, once we have simplified the numerator, now we can write it along with the denominator. So that will become minus sine squared minus 1 divided by cos squared. And the denominator is cos squared. So we can write it as divided by cos squared. So over here, we can first change the division sign and write it as multiplied by 1 upon cos squared. So that will be equals to minus sine squared minus 1 upon cos to the power 4 theta. And as we need a 1 in the numerator, as it says minus 1 upon cos to the power 4 theta. So if we take, and this was, and if we had taken the LCM, this should have been a cos squared up here. So just to make a correction, this will be a cos squared up here. So all along this way, this will be not 1 over here. When we take the LCM, this would have multiplied by cos squared. So this would have been cos squared over here and over here as well. So now if we take the negative sign common out over here, so that will become sine squared plus cos squared divided by cos to the power 4. Now as sine squared plus cos squared is 1, so that will become a minus 1 upon cos to the power 4 theta. In part B, it says find the exact value of the 13th term when theta is equals to 1 upon 6 pi. Now we know that the nth term of an arithmetic progression is given by a plus n minus 1 into d. So the first term in this question was given as 1 upon cos squared. So we can write it as 1 upon cos squared theta plus n minus 1. So that will become 13 minus 1 into d, which is 1 upon cos to the power 4 theta. Now to find the 13th term, we know that the value of theta is 1 upon 6 pi. So this will become 1 upon cos of 1 upon 6 pi whole squared plus 12. And in the denominator, we have cos to the power 4 theta. So cos to the power 4 will become, so this is theta is 1 upon 6 pi. So this will become cos of 1 upon 6 pi to the power 4. Now to simplify this, we know that if we substitute cos of 1 upon 6 pi in the calculator, and we'll make sure that the calculator is in radian mode. So cos of 1 upon 6 pi is equals to square root of 3 upon 2. So when we have square root of 3 upon 2, if it is a whole squared over here, as we have over here cos of 1 upon 6 pi whole squared, so that will become 3 upon 4. So over here in the denominator, that will be 1 divided by 3 upon 4. And if we have to the power 4, so we can whole square 3 upon 4 again. So if we whole square 3 upon 4, as it is power 4 over here, so that will become 9 upon 16. Now, once we have the values of cos to the power 4 and just one correction over here, this was with a negative sign over here. So the common difference was with the negative sign over here, so that we'll have a negative sign with 12 over here. So this will become a minus over here, and 12 divided by 9 upon 16. Now we can simplify it and write it as, so the 13th term will over here, the 4 will go into the numerator, so that will become 4 upon 3 minus the 16 will go into the numerator, and that will become 12 into 16 divided by 9. We can simplify it with 3, so 3 times, 3 4 times. So the 13th term will be equals to 4 upon 3 minus, and this will become 64 upon 3. Taking the LCM over here, so or as 3 is already the common denominator, so 4 minus 64 is minus 60, minus 60 divided by 3. So the 13th term will be equals to negative 20. In question 8, the equation of a curve is y equals to 2x plus 1 upon 2x plus 1 for x greater than negative half. We have to find dy dx and d square y upon dx squared. So if we have to find the dy dx, we'll first bring the variable that is in the denominator and bring it in the numerator and write it as 2x plus 1 to the power minus 1. Now finding the dy dx. So differentiating 2x, that will become a 2. Differentiating 1, that will become a 0. And differentiating this bracket over here, so the minus will multiply by the coefficient, so that will become a minus into 2x plus 1. The power will decrease by 1, so that will become a minus 2. And we'll also multiply it with the derivative of 2x plus 1, which is positive 2. So the dy dx will be is equals to 2 minus 2 into 2x plus 1 to the power minus 2. Once we have the dy dx, to find the double derivative, or d square y upon dx squared, we'll differentiate this again. So this will become, the derivative of 2 will become a 0. Minus 2 times minus 2 will become a plus 4 into 2x plus 1. The power will again decrease by 1, so that will become a minus 3. And we'll multiply it with the derivative of 2x plus 1. So finally, this answer will be 8 into 2x plus 1 to the power minus 3, or we can also write it as 8 upon 2x plus 1 whole cube. In part B, it says find the coordinates of the stationary point and determine the nature of the stationary point. Now, when it is a stationary point, it means that dy dx will be equals to 0. We already have an expression for dy dx, which was 2 minus 2 into 2x plus 1 to the power minus 2. So as the dy dx was 2 minus, well, it was 2 minus 2 into 2x plus 1 to the power minus 2. We'll put it equals to 0. Now to simplify this, we can take this on the right hand side to make it positive and bring the 2x plus 1 in the denominator. So that will become 2x plus 1 whole squared. Taking 2x plus 1 whole squared on the left hand side, we'll get 2x plus 1 whole squared is equals to 2 upon 2. And this will cancel out. So 2x plus 1 will be is equals to 1. And this is a whole squared. Now taking the square root on both the sides. So taking the square root of 1, we'll get plus minus 1. So this will become 2x plus 1, and that will be equals to positive 1. And as it is a square root, so it can be a minus 1 as well. So 2x will be is equals to, if we take the value of x as positive, so this will become x is 1 minus 1. So x will be equals to 0 upon 2, which will be 0. And if we take the negative value as well, so that will become 2x plus 1, and that will be equals to negative 1. So 2x will be is equals to minus 1 minus 1. and x will be is equals to -2 upon 2, which is -1. Now over here, as it said that x has to be greater than -1 upon 2, it means that we will not be able to take this value of x, which is -1, as x is greater than -1 upon 2 and -1 is less than 1 upon 2. So now once we have the value of x over here, as we have to find the coordinates, now we can find the y value as well by substituting this value of x in the equation of the curve. So the equation of the curve was given as y is equals to 2x plus 1 plus 1 upon 2x plus 1. So substituting 0 over here, we'll get 0 plus 1 plus 1 upon 0 plus 1. So the y coordinate will be is equals to 2, as this will become y is equals to 1 plus 1 upon 1. So the coordinates of the stationary point are 0, 2. And to find the nature of the stationary point, we will substitute this x value 0 into the double derivative. So the double derivative that we got in the previous part was, so that was equals to 8 upon 2x plus 1 whole cube. Substituting x equals to 0 over here, so that will become 8 divided by 0 plus 1 whole cube, which is 8 upon 1. As 8 is greater than 0, it means that it will be a minimum point. In question 9, in the diagram, arc AB is part of a circle with center O and radius 8. Arc BC is a part of a circle with center A and radius 12, where AOC is a straight line. In part A, we have to find angle BAO. Now, to find angle BAO, we have a triangle BAO where all the three lengths are given, so we can apply the cosine rule. So this will become, as the length facing this angle is 8, so the cosine rule will become 8 square is equals to 8 squared plus 12 squared minus 8 minus 2 into, so that will become minus 2 into 8 into 12 cos theta. Rearranging this, we can write this as 2 into 8 into 12 is equal cos theta. We'll take this on the other side to make it a positive, so that will become 2 into 8 into 12 cos theta is equals to 8 squared plus 12 squared minus 8 squared. So 8 squared and 8 squared will cancel out. Cos theta will be is equals to 12 squared divided by 2 into 8 into 12. So 12 squared is 144. So 144. So we'll do 144 divided by 2 into 8 into 12. And taking shift cos inverse of the answer, so that will become theta will be is equals to 0.7227 radians. Now, as our angle, we'll have to give this answer in 3 significant figures. So the final answer, we can give it as 0.723 radians. In part B, it says find the area of the shaded region. Now, to find the area of the shaded region, we can find the area of this triangle and then subtract it from the area of the sector. Now, to find the area of the sector BAC, so in the first step, we can find the area of sector BAC. The area of the sector is given by the formula half r squared theta. So the radius of the sector is 12 and the angle was 0.7227. So this will become half into 12 squared into 0.7227. Substituting this in the calculator, so that will become 52.036. So the area of the sector is 52.036 centimeters squared. Once we have the area of the sector, now we can find the area of the triangle by applying half AB sine C, as we already have this angle as 0.7227. So the two lengths we can use are 12 and 8. So the area of triangle will be half, using the formula half AB sine C. So this will be half into 8 into 12 into sine of 0.7227. So sine of 0.7227, that is equals to 0.661 multiplied by 12 multiplied by 8 and then dividing by 2. So the area of the triangle will be 31.747 centimeters squared. And then finally, the area of the shaded region will be the difference of the two areas of the sector and the triangle. So this will be 52.036 minus 31.747. So 52.036 minus 31.747, that will be equals to 20.288. And as we have to give our answer to three significant figures, so we can write the final answer as 20.3 centimeters squared. In part C, we have to find the perimeter of the shaded region. Now, the shaded region consists of the length PO, the length OC, and the arc length PC. So we have two lengths, straight lines BO and OC, and the arc length BC. Now, from the question, we know as the radius is 12 of the length of AB is 12, it means that the length of AC will also be 12, which means that as AO is 8, this will be 4. This length is already given, so we just need to find the arc length BC. So the arc length is given by the formula S is equals to R theta. We know that the radius is 12 and the angle is 0.7227. And just a reminder, we'll always use the complete values and only round off in the final answer. So if we have 0.723 as a final answer for the angle, we'll still use the original value for the calculations and then round off later on. So now multiplying 12 multiplied by 0.7227, that will be equals to 8.6724 centimeters. And finally, the perimeter will be equals to, so one of the lengths was 8, the other length was 4. So this will become 8 plus 4 plus 8.6724. Adding them up, the answer will be 12 plus, so 12 plus 8.6724, that is equals to 20.6724. And finally, giving an answer to three significant figures, so that this will be 20.7 centimeters for the perimeter of the shaded region. Question 10, a curve has equation y equals to 1 upon k x to the power half plus x to the power minus half plus 1 upon k squared, where x is greater than 0 and k is a positive constant. In part 8 is given that x equals to 1 upon 4. The gradient of the curve is 3. We have to find the value of k. Now, as the gradient is 3, it means the dy dx is equals to 3. So in the first step, we'll find the dy dx of the curve, and that will be equals to, so 1 upon 2 will multiply by the coefficient, which is 1 upon k. So that will become 1 upon 2k. And x to the power, it will reduce by 1. So that will become minus 1 upon 2. In x to the power minus half will multiply by the coefficient. So that will become 1 minus 1 upon 2, x to the power minus 3 upon 2. And when we differentiate 1 upon k squared, that becomes a 0. So once we have differentiated, now we know that the value of x is 1 upon 4 and the gradient is 3. So we can write this as, okay, so first we can rearrange it and write it as 1 upon, bring it in the denominator and write it as 2k square root of x. And this will become minus 1 upon 2. And now x to the power, so if you bring it in the denominator, that will become x to the power 3 upon 2. Or we can also write it as square root of x whole cubed, as x to the power 1 upon 2, and if you whole cube it, that will become 3 upon 2. So it's up to us how we can write it. So I will write it as square root of x whole cubed, and that is equals to 3. Now substituting x equals to 1 upon 4, so that this will be 3 is equals to 1 upon 2k, and this will be square root of 1 upon 4 minus 1 upon 2 into square root of 1 upon 4 whole cubed. Simplifying this, so this will become 3 is equals to 1 upon 2 k into 1 upon 2 minus, this will become 1 upon 2 into 1 upon 2 whole cube, as square root of 1 upon 4 is 1 upon 2. So this will become 1 upon 2 whole cubed. Now simplifying this, 2 and 2 will cancel. So this will be 3 is equals to 1 upon k minus, and this will become, we can write it separately over here, 2 into 1 upon 8. So this will become 1 divided by 1 upon 4, which will become, we will bring the 4 in the numerator and write it as 3 is equals to 1 upon k minus 4. Taking the 4 on the left hand side, we'll get 3 plus 4 is equals to 1 upon k. And now cross multiplying, so this will be first 7 is equals to 1 upon k. The final value of k will be equals to 1 upon 7. In part B, it says it is given instead that the integral of one of the equation with the limits k squared and 1 upon k squared The answer is 13 upon 12. We have to find the value of k. So in the first step, we'll integrate the expression and then substitute the limits. So integrating 1 upon 2x to the power 1 upon 2. So the power will increase by 1 and that will become x to the power 3 upon 2. And we also divide by the new power. So this will become dividing by the new power, that is 3 upon 2 over here, plus x to the power minus 1 upon 2. So this will increase by 1 and then we'll divide it by the new power, which is 1 upon 2. And integrating 1 upon k squared. So we'll just add an x over here. Now, once we have integrated this, we'll first substitute the limits and subtract them and then put the final answer equals to 13 upon 12. Before we substitute the limits, we can rearrange this to write it as 2 upon 3k, and this is x to the power 3 upon 2 plus 2x to the power 1 upon 2 plus we can write it as x up 1 upon k squared x. So once we have simplified this, now we can apply the upper limit, which is k squared. So now using x equals to k squared, we'll get 2 into k squared to the power 3 upon 2 upon 3k plus 2. So we have k squared and this will be to the power 1 upon 2 plus 1 upon k squared and x value is k squared. Now simplifying this, so the first term, which is k squared to the power 3 upon 2, that will become, so 2 into 3 upon 2, that will become 2k cube. So we'll have 2k cube upon 3k. K squared multiplied by 1 upon 2 will become k, so that will be plus 2k. And over here, k squared will cancel, so we'll have a plus 1. So k and k cube will cancel, so the final expression for this upper limit will be 2k squared upon 3 plus 2k plus 1. And we'll have to subtract this from the lower limit. So the lower limit is 1 upon 4k squared. Now substituting x is equals to 1 upon 4k squared into the equation, we'll get 2 into 1 upon 4k squared to the power 3 upon 2. And we already had 3k in the denominator plus 2, and x is now 1 upon 4k squared to the power 1 upon 2 plus 1 upon k squared, and now again x value is 1 upon 4k squared. So simplifying this, first of all, so k squared into 3 upon 2 will become k cube. So this will become 2k cube upon 4 to the power 3 upon 2 is 8. 8 times 3 will become a 24. So this will become 24k plus square root of 4 is 2. So that will become 2 upon 2 will cancel out. And this will be k squared into 1 upon 2, which is just k over here. K squared and k squared will cancel out. So that will be equals to plus 1. So we have the value with after substituting the lower limit, and we can simplify to write it as 1 upon 12. And this k will cancel. So 1 upon 12 k squared plus k plus 1. And this is 1 upon 4. So plus 1 upon 4 over here. Now subtracting the two values for the upper limit and the lower limit, and then we can equate it equals to 13 upon 12. So the value with the upper limit was 2k squared upon 3 plus 2k plus 1. And we'll subtract it from k squared upon 12 plus k plus 1 upon 4 and put it equals to 13 upon 12. Okay, so we don't have enough space left over here. So first we can take the LCM on the whole left hand side. So if we take the LCM on the whole left hand side, this denominator is 12. So the LCM will be 12 up here. So we'll have to multiply this by 4. So this will multiply by 4. That will become a 8k squared. This will multiply by 12. So this will become a 24k. This will also multiply by 12. This will become a 12 minus. So in the brackets, we will have. So this will remain as k squared. This will also multiply by 12. So k will multiply by 12. We'll have a plus 12k. And this will multiply by 3. So this will become a plus 3 is equals to 13 upon 12. So this 12 and 12 we can cancel out. Now 8k squared minus k squared will become a 7k squared. So 24k minus 12k over here, as this will become a minus plus minus. So this will become a minus 12k. So that will 24 minus 12 will become a plus 12k. and this is 12, and this is, so this will be 12 minus 3, which is equals to 9. So we'll have my plus 9 is equals to 13. Simplifying this, we'll get 7k squared plus 12k. 9 minus 13 is a minus 4 equals to 0. Factorizing this through middle term breaking, so we can just do the working over here. This will become 7k squared plus 14k minus 2k minus 4 equals to 0. Taking 7k common, so that will become k plus 2. Taking 2 common, that will be equals to k plus 2 equals to 0. Now, as k cannot be a negative value, so k is equals to minus 2 will not be considered, and the other value of k will be equals to 2 upon 7, which will be the final answer for the value of k. So k will have the value 2 upon 7. In question 11, a circle with center C has equation x minus 8 whole squared plus y minus 4 whole squared equals to 100. In part A, we have to show that the point T minus 6 comma 6 is outside the circle. Now, if we have to show that the point is outside the circle, it means that, let's say if we have a circle and the center point is 8 and 4 as from the equation. To show that minus 6 comma 6 is outside the circle, so let's say the distance between the point minus 6 comma 6 and the center must be greater than the radius. And as we can see that r squared is 100, so the radius in this case will be equals to 10. Now, if the radius is greater than 10, it means that t will be outside the circle. So finding the distance of CT, so CT will be, we know that the coordinates of the center will be 8 comma positive 4, and t has coordinates minus 6 comma 6. So applying the distance formula for CT, we'll get x2 minus x1, which is minus 6 minus 8 whole squared plus, and this will become 6 minus 4 whole squared. So 6 minus 6 minus 8 is minus 14, and minus 14 whole squared will be equals to 196. And 6 minus 4 is 2, so 2 squared will be 4. So the distance CT will be is equals to square root of 200. And as this is greater than 10, it means that the point T lies outside the circle. In part B, it says two tangents from T are to the circle are drawn. Show that the angle between one of the tangents and CT is exactly 45. Now, let's make a circle over here again. And assuming that this is the point, this is the center, and point T was, let's say, up here. So we are drawing two tangents from T. So one of the tangents will be over here. One of the tangents will be passing through the circle like this at a tangent. Now, to show that the angle, we can first make a line over here. And we know that a tangent makes a right angle with the center of the circle. Now, the distance CT is already known. We know that this distance is square root of 200. The radius is 10. So to show that the angle that the tangents and CT is 45, so we know this is a right angle. So we can use opposite over hypotenuse. So we can use sine, let's say this will be sine theta is equals to 10 divided by square root of 200, as 200 is the hypotenuse. So theta will be is equals to sine inverse of 10 upon square root of 200. Substituting this in the calculator, theta will be is equals to, so that will be is equals to 45 degrees. In part C, it says find the equation of the line AB, giving your answer in the form y equals to mx plus c. So again, to understand this, we'll make the circle over here, the tangent, the point T over here. Let's make the two tangents again. And we have to find the equation of the line AB. So let's say this is the point A, this was the point B, as the tangents are touching the circle at point A and B, and this was the center of the circle, which is C. So to understand how to find the equation of line AB, we know that this is the center. And let's say we know that as the angle is 45 up here, so let's first draw it. We know that this angle is 45 because this angle is 45, which means that these two lengths are equal. Now, if we have a quadrilateral where all the lengths are equal, as if this is x, so this will also be x, and we already know that this is not x, this is 10, but just for understanding, this is x, this is x, this is x, and this will also be x because the angles are same. This is 90 and all these angles are 45, 45. So we know that all these lengths are same, and if we have a quadrilateral where all the lengths are equal, so let's make a first a quadrilateral over here, and we know that all the angles are equal over here. uh, yeah, so over here we know that this angle and this angle is equal. So to find, and let's call this point as C, this point is B, and this point is A over here. So if we draw a straight line from over here up to this point, this will be the center point over here. As these two angles and these two angles are equal, it means that this point will be the midpoint of the line CT. So if I make a line from A till B, as all these sides are equal, it means that this point will be the midpoint. Now to find the equation of the line AB, we need a point on the line AB, and the point on the line AB will be the midpoint of CT, and that is because all these lengths are equal. So first, finding the midpoint of CT, that will be equals to x1 plus x2 upon 2. So we know the coordinates of C and T are 8, 4, minus 6, 6. So that will become 8 plus minus 6 upon 2, and this will be 4 plus 6 upon 2. Simplifying this, we'll get 8 minus 6, which is 2 upon 2, comma 10 upon 2. 10 upon 2. So the coordinates of the midpoint of AB, or the coordinates of the midpoint of CT, which will be equal, are 1, comma 5. Now to find the gradient of the line AB, as it is a perpendicular, it will make a perpendicular over here. So finding the gradient of CT, to find the equation of AB, first we'll find the gradient of CT, that will be y2 minus y1. So this will be 6 minus 4 upon x2 minus x1, which will be is equals to minus 6 minus 8. Now the gradient of CT will be 2 upon minus 14, which is equals to minus 1 upon 7, which means that the gradient of AB will be a negative reciprocal, which will be is equals to positive 7. Once we have the gradient of AB and a point on AB, so the equation will be y minus y1 is equals to m, the gradient, which is 7, into x minus x1. So x1 is 1, so that will be x minus 1. We can simplify this to write it as y is equals to 7x minus 7 plus 5. So the final equation will be y equals to 7x minus 2. In part D, it says find the coordinates of A and B. Now, as we already have the equation of AB, which is 7x minus 2, and we have the equation of the circle, we can solve this equation simultaneously to find the x coordinates of A and B. So the equation of the circle was x minus 8 whole squared plus y minus 4 whole squared and equals 200. So in place of y, we can substitute 7x minus 2. So this will become x minus 8 whole squared plus 7x minus 2. And this will be a plus 4 over here. So 7x minus 2 minus 4 whole squared equals 200. So expanding this will become x squared minus, so 2 times x times 8 will be 16x plus 64. And first we can simplify. So this will be 7x minus 6 whole squared equals 200. Now expanding, x squared minus 16x plus 64, and this will become, so 49x squared, and this will become minus 2 into 7 into 6. So that will become an 84x, and minus 36. So this will become a plus 36 equals 200. So minus 16 minus 84 will become minus 100, and 49 plus 1 will become 50. So this will become 50x squared minus 100x, and that will be is equals to 64 plus 36 is 100. So on the left hand side, we will have 100 minus 100, which is equals to 0. So once we have 50x squared minus 100x equals to 0, we can take 50x common, and this will become x minus 2 equals to 0. So one of the values of x will be equals to 0, and the second value will be x will be equals to positive 2.